Hello everyone. Today I am starting continuity and differentiability for class 12. I will be solving all the examples from R.S. Agarwal. So this is the first example. Show that fx is equal to x cube is a continuous function at x is equal to 3. I'm sorry, it is at x is equal to 2. To show the continuity, we have to check three things of a function. Left hand limit, let me call it left hand limit, right hand limit, and the function value at that point at which we are checking the continuity. Those all three should be exactly equal. Then we say that function is continuous. So left hand limit is represented as x is tending to a minus of fx. Right hand limit is limit x is tending to a plus f of x, and functional value at the same point at which we are checking the continuity. So if these three things are equal, the left hand limit, right hand limit, and the function value, then we say the function is continuous. Okay, so we will check one by one. Let's check left hand limit. Limit x is tending to, we need to check at 2. So we will write 2 minus. 2 minus means here if we have to check the continuity at 2, 2 minus means a number which is lesser than 2 but very close to 2. And for right hand limit, we check at a number slightly more than 2, which is 2 plus. Okay, so this is the representation 2 minus, and then we just write fx. Okay, so this will be limit x tending to 2 minus, and what is fx here? Is x cube. Okay, to find the limit, we directly put the value of x at which we need to check it. Here we need to check it at 2. We can directly put the value and get the answer. We sometimes, you would have observed, for limits we use two methods. One method is called H method, and one method sometimes we use delta x method. These methods are used only when we have some fractional questions, or where we have 0 by 0 problem, or we have infinity by infinity problems. Okay, or we have some fractional questions. In those questions we will use H methods. In coming questions I will explain you. For such type basic polynomial questions, no need to use H method. So this is your left hand limit. Fine. Right hand limit is limit x is tending to 2 plus of fx. 2 plus is nothing, it is just a representation that x is tending towards 2, but it is little bit, tiny bit more than 2. So here x is tending to 2 plus, function value is x cube. Okay, so we will directly put x is equal to 2 because this is not a fractional function, or we don't have any 0 by 0 function here, right? So this is 2 cube, which is 8. So this is my RHL. So you can see we are having LHL and RHL already seen. Now we will find the function value. The third thing that we have to check is the functional value, which is f of 3. F of 2, because we are supposed to find the value of function at 2. So let me solve it. F of 2. So it will be 2 cube. 2 cube is also 8. So we can see clearly here we got 8 LHL, RHL and function value. So we can declare, since LHL is equal to RHL is equal to function value, that's why it is continuous at x is equal to 2. Let's see second question. This is example 2. It says, show that fx x, which is the greatest integer function, this is called greatest integer function, is continuous at x is equal to n. To understand this problem, we should know what is greatest integer function. Greatest integer function is a function where we take integer part only. Let me show you. Suppose you have 2.785. So the output of this function will be only integer part 2. If suppose you have 0.25, it will have the integer part only 2. But for a negative number, it changes little bit. See here, if there is a greatest integer function for a negative number, let me show you, then we take the greatest integer which is closest to this. For example, this is 0, minus 1, minus 2, here is minus 3. So my integer is minus, this number will fall somewhere here. So the nearest integer on the left side, is minus 3. The greatest integer function means we take the integer part only, or I can improve it, part on the left side of number. Okay, one more example, let's see. Say you have 3.59. So if this is the number, correct? If I want to represent it on a number line, it will come like 1, 2, 3, 4, 5. So this 3.59 will fall somewhere here, correct? 3.59. So what is the left side integer? Remember, left side integer is 3. So we will take 3. So this is the key point here. We take the integer which is on the left side of the given number. I hope you understood. Now using this definition, we will try to find whether this given function is continuous or not at some integer, okay, at any integer. So to make it simple to understand, I will take n as a number, say 2. So I will test its continuity at 2 and show you how to check it. Let's take it. Here is the function fx is equal to fx is equal to, it is a greatest integer function which is x, correct? So we have to check at 2. So let me check first left hand limit. So it will be limit x is tending to 2 minus, right, 2 minus of function, right? What is the meaning of 2 minus? 2 minus means there is a number which is very close to 2 but little bit less than 2, okay, little bit less than 2. So here, instead of solving it directly, we can use H method. In H method, what do? We simply write x is tending to 2 minus h. You know, x is tending to 2 negative. 2 negative means little bit less than h. H is just a representation for a very tiny number. It may be 0.000001. It is just a representation of a tiny number h. So very close to 2 का मतलब it may be x may be 1.999999. Okay, and what we can write is 2 minus 0.00001. Correct? Or we can write x is equal to 2 minus this h. So that is how we can represent 2 minus limit 2 minus h. Similarly, if I have to write x is tending to 2 plus, so we write x as 2 plus h. That's how we can write. And when x is equal to 2 plus h, at that moment your h or 2 plus h, at that moment h is tending to 0. So in H method we make these changes in the question. Okay, what do? We write x as 2 minus h. Listen carefully, because in coming questions we will directly replace it. I will not explain again that what is the meaning of h. Okay, so h is a very tiny number which is used to represent 2 minus or 2 plus or 3 plus or 3 minus. Okay, so here to represent 2 minus I am using 2 minus h. So let me change the question, not the question, the how to use H method. So here h is tending to 0 and instead of x we got 2 minus h. Okay. Now I am ready to open this greatest integer function. So when I will open this greatest integer function 2 minus h, that means approximately what is inside. It is some number. If I think it is maybe it is 2 minus h, it may be 1.999 something. So what will come out of greatest integer function will be 1, because I will drop the decimal part and I will get only 1. Correct? This is left hand limit. We are done here. Now we will see a right hand limit. Limit x is tending to 2 plus greatest integer function of x. To solve greatest integer function, I will again apply what? H method. For H method, I will use limit h is tending to 0. Correct? What I told to be used for H method. See here, x is replaced by 2 plus h and h is tending to 0. That's how we do. So x is replaced by 2 plus h. Okay. So that means it is 2 plus something. Greatest integer may it is 2 plus something. Means maybe it was 2 point something something like this. Very close to 2. Approximately it may be 0.0001. It is just a representation. Okay, h, because of h. So what will come out of this? Will come out 2. So we can already observe that left hand limit was 1 whereas right hand limit is 2. It doesn't seem to be continuous. But let me check the function value also at 2 itself. Correct? So let's check. Fx is this. So what will be f2? F2 will be this. So greatest integer of function of 2 will come out is 2 only. So we can see clearly LHL is something else, RHL is something else, and function value is also not matching. So I can declare LHL is not equal to RHL is not equal to fx. So that means it is not continuous at x is equal to 2. Fine. Similarly, we can prove for number 3, or we can say for any integer it will not be continuous function. See one more question. This is third example. Fx is x if x is integer and 0 if x is not integer. Okay, so you have to prove that it is a discontinuous function for any integer, or at any integer value. Prove it is discontinuous at any integer. At any general integer, it's very difficult to explain. Let me explain with one example and then we will make it general. So let x is equal to 3. This is some integer. Okay, just for explaining purpose, I am taking it some integer. So let's calculate LHL. So it will be limit, right? Limit x tending to 3 minus, that's how we do for LHL, right, of fx. 3 minus means it is x is very close to 3 but not exactly 3. So what we will get? Okay, so wherever we have such type of problem, let me use H method. Okay, so for H method, what do we do? Limit H is tending to, in H method, what do? We replace the x by 3 minus h and we say h is tending to 0. That's how we do, right? Whatever is the number at which we have to find the limit, that number minus h, where h is a very tiny number, that's why we say it is tending to 0. So h is tending to 0, f of 3 minus h. 3 minus h. So now what is 3 minus h? Is it an integer or non-integer? 3 minus h will be some number, say 2.999 something, very less than 3 but very close to 3, right? 2 point. So is it integer? It's not integer. So what should I take value here? When it is integer, it should be x, right? I should take this value of function. When it is not integer, I should take this value of the function, right? Function is having two possible values, either x or 0. X, if this number which is inside x is integer, so I take x out. But if this number is not an integer, then I take 0. So what is this number here? It's not an integer, right? I don't think it's an integer. It's not integer. So if it is not integer, what will come out is 0. That's it. So I am getting left hand limit 0. Okay, let me write down here. This is 0. Let's calculate RHL. Fine. RHL. In RHL we take limit x is tending to 3 plus, remember, very close to 3 but little bit more than 3. So this is fx. So limit, again I am using h method. So here h is tending to 0, f of what the x will be replaced by? 3 positive. 3 positive means 3 plus h, little bit more than 3, correct? So now I have to write the function and solve it. So which function I should choose? Which value? X or 0? X or 0? Sorry. I should take x or 0. Here 3 plus h seems to be maybe 3.00001. very close to 3 but more than 3. So I don't think it is an integer. Correct? It's not an integer. So if it is not an integer, what should come out? This definition should come out 0. So far LHL and RHL seem to be equal. Let's check the function value. Okay, function value is f itself on 3, function itself on 3. So on 3, 3 is an integer. So I should take this definition now, this one. This is integer itself. So I should take it is an integer. So what will come out is x itself. If it was x, then x will come out. If it was 3, then I will get 3 itself. So clearly I am not getting these 3 values equal. My LHL is equal to RHL but not equal to f of 3. Okay. So by looking at this, I can declare that it is discontinuous. Fine. So this I checked for a number 3. We can do this similarly for any general number n, easily in the same way. Okay, I hope you can try it on your own. Bye everyone.